This is lecture 21, CS147 Computer Architecture Study. This is the third part of our cache memory study, and in this part we will be concentrating on the handling of the cache miss. As I mentioned that this data transfer between the hierarchies is not done by control unit directly. It takes help of some other unit called memory management unit, or MMU. In a chip design, like these are MMU also part of the control unit in some sense, and but we want to like look at this memory management unit separately than the control unit, because like they serve different purpose and they can essentially run in parallel. Okay, so in a very simplistic sense, this is one of the configuration, or one of the logical connection, you can say. There can be many other architecture, many other similar or little bit different architecture around a connection between the control unit and the memory management unit. But the idea is this: like we have seen a highest level memory, let's say this is L1 cache, the top one, and a cache memory can produce hit or miss signal. So upon requesting an data information retrieval from a control unit through the address, specifying an address to the memory, the top level memory that it is directly connected to, it can send out something like an hit and miss to control unit, and control unit can detect that hit and miss signal. And if it is a miss signal, then what control unit request to the memory management unit is that, hey, I was trying to access this address, it is not there, so do something about it so that I can get the information back. So it request is kind of a sender request to the memory management unit, and then memory management unit, what it does, it basically try to access the corresponding block that belongs to that address, or this address belongs to whatever block it tried to access from the lower level memory. Let's say this hierarchy has three levels like L1, L2, and the main memory. So top one is the L1, middle one is the L2, and the lowest one is the memory. So we assume that the information of corresponding this address would always be present in the lowest level of the memory, right? It's present in the RAM. But it might happen that L2, this middle level, may not have that, or may have that, we don't know. So this memory management unit first initiate a data transfer, block transfer from the low L2 memory to the L1, okay, from the middle one to the top one. And if that corresponding block present in this middle of the hierarchy, like L2 memory, L2 cache, then it is copied back to the L1 cache. But if it is a miss, that is what the hit and miss signal from the L2 is going directly to the memory management unit. It detects that, then it initiates the block transfer from the lowest memory, which is RAM in this case, to the L2. So once that block transfer is done, then that block been copied from L2 to L1. So once the L1 got the corresponding block copied, memory management unit sends a down signal to the control unit, and then this control unit issues that address again to the L1 cache, and this time certainly it will get a hit because it has been copied by the memory management unit. So throughout the process, the simplest thing that control unit can do is to wait until the memory management unit is done. So this wait part is actually exploited by that hardware threading. If you recall that our hardware threading parallelism that we discussed, exactly hardware threading exploit this scenario. Instead of waiting when memory management unit is busy in like transferring the blocks from the lower level memory to higher level memory, it tries to like pull through some parallel instructions in its instruction cache, and is what they call it a strand. It switch to the another strand and try to complete that while memory management unit is busy in copying back and forth this block, right, throughout this level of hierarchies. And of course, there can be situation that the next strand also had a miss. Then you initiate another block transfer to the memory management unit to go to the next strand. There can be a hit or miss. So depending on that, situations are handled. But let's not go into that complicated scenario. For us, the simplest assumption is that once it initiate the memory management unit, control unit goes to the wait state. So, okay, so it's wait there till memory management unit is done.